Welcome to myprojectbazaar.com. Now we are going to discuss about the product brain tumor classification using deep CNN features via transfer learning. Now we are going to discuss about the abstract of the process. Brain tumor segmentation and classification are an integral part of both computational intelligence and pattern recognition systems. In this process, an efficient algorithm was implemented in segmentation of affected portions and is carried out, and its features such as the convolutional neural network to extract the feature value from the image. Hence, in this process we have two major steps like feature extraction and classification plays a major important role in this process to classify the images normal or abnormal. Hence, in this segmented step, it is based on the algorithm named as the morphological and thresholding is proposed for segment the tumor and non-tumor portion separately. Hence, some of the image having the tumor region means that tumor regions will separated and then the other backgrounds will be eliminated. On the other hand, the output is indicated as a binary image. Hence, the black region, which is the background, indicates the background. Then the white region, that is the segmented portions, which indicates the tumor position. Then this process involved here in the medical field to detect the brain tumor and its feature classification method with multi-class support vector machine classifier, which helps to classify the tumorous and non-tumorous results from the brain input. The machine learning performance was evaluated by means of the three kinds of commonly used performance parameters like accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. First of all, the modules such as the input image, pre-processing, segmentation, feature extraction, classification and performance estimation. Now we discuss about the flow diagram. First stage is the input image. In the input image, we are going to take the input image from the dataset. The dataset consists of all kind of brain tumors. It is having the tumor as well as the non-tumorous image. After getting any one image from the dataset, we just move on to the next stage of the project, that is the pre-processing. In this pre-processing, we have two stages of pre-processing. One is the image resize, then the another one is the grayscale conversion. Image resize, in the sense we have to change the dimension of the image into an aspect ratio of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After resizing the image, we are go for the image grayscale conversion. If it is an input image is the RGB image, then it will be converted into a grayscale form. After converting the image into a grayscale form, we just do the segmentation. Segmentation, in the sense we have to segment the affected portion. For example, if the input image having the region of tumor means the particular region of tumor will be extracted, that is the segmentation. Here we are using the threshold and morphological algorithm to segregate the region of tumor portion. After extracting the tumor portion, we just move on to the feature extraction. In this feature extraction step, we are using the CNN, that is the convolutional neural network method, to extract the features from the image. Feature is nothing but the collection of data from the image, that is in the pixel wise form. After extracting the data, we are going to do the classification step. In this classification step, we are using the support vector machine classifier to classify the input image is the normal one or abnormal one. If it is a tumor means the classification report will generate the output as a tumor or abnormal image, or else the classification results will generate as a normal one. Finally, the final stage of the performance process is the performance estimations. In this performance estimations, we have three categories of performance parameters is there. One is the accuracy, then the second one is the sensitivity, and the third one is the specificity. Now we are going to discuss about the initial running procedure of the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.yum and select the option run. Now the user interface was open. In that user interface, there are several push buttons in the right side for the controlling actions, and then the several axes and tables in the left side for the display purpose. First of all, click the button input image. After clicking the button input image, you have to open the dataset and then select any one image from the dataset. After the selection of the input image from the dataset, the corresponding image is shown in the axis 1 with the title input image. After the selection of input, we just move on to the second step of the process, that is the pre-processing. In this pre-processing, we have two kinds of pre-processing is there: the image resize, filtering, and grayscale conversion. First of all, the image resize. Whatever the dimension of the input, it will be resized into 256 × 256. Here you can see the difference between the input and resized image. Here the dimension of the row and column will be changed. After the resize, we just move on to the grayscale conversion and filtering. If the input is already the grayscale image, it will remain the same, or else the input having the RGB channels means it will convert it into a grayscale form. After that, the filtering is done to remove the noise present in the image. If the noise is present in the image, the filtering will remove the noises. After the filtering, we have to apply the segmentation. In this segmentation process, we are applying the threshold and morphological to eliminate the background and to extract the foreground region. Here the tumor is the foreground region. Only the tumor portion will remains extract, and then other regions should be eliminated. The extracted regions will be in the form of white regions. The eliminated regions will be in the form of black pixels. After the elimination of the background, we just move to the feature extraction. In this feature extraction, the feature values will be extracted from the image. Then we just move to the classification step. In this classification step, the CNN will extract the basic features from the image. Then based on that features, it will decide whether the input is then normal or abnormal. If it is a tumor image, it will goes for the abnormal category. If it is a non-tumor image, it will go for the normal category. After the classification, we just move on to the final stage of the project, that is the performance estimation. In this performance estimation, we have three kinds of performance parameters, that is the accuracy, sensitivity, and specificity. Those values are plotted here. Thanks for watching this video.